Hello, welcome to my presentation. I'm Mohammadnia from IASBS University in Iran. I'm going to talk about InSAR constraints on the active deformation of soft diapirs in the Kalut basin located in central Iran. Let me start by introducing the study area. As you see in this slide, the central basin of Iranian plateau represents uniquely abundant, well-exposed and well-preserved soft diapirs. Central Iran includes several salt provinces such as Great Kabir, Mousavi, Gamsar, and Kalut Basin, as you can see by the red color on the map. In this study, we focus on the Diapir province of the Kalut Basin, located in the southeast of the central Iran. This basin includes elongated elliptical and circular dams, showing extrusions of exceptionally pure white and massive diapirs. In this study, we mapped the salt structures using Landsat images. As for InSAR, we used 75 and 62 images of Sentinel for ascending and descending tracks, respectively. You can see network of interprograms according to coherence in this slide. This results shows mean velocity map in millimeter per year of Kalut basin along the line of sight direction. According to color bar, red color corresponds to motion toward the satellite and blue color corresponds to motion away from the satellite. The considerable similarity in terms of magnitude, direction, and location of the formation is seen in the ascending and descending results. The same areas in terms of displacement in both geometries can suggest that the formation is mostly vertical in this basin. Uplift areas coincide very well with the location of salt structures and rivers according to simplified geological map. And then we combine ascending and descending to decompose vertical and horizontal components. These figures illustrate the average annual displacement rates along the horizontal and vertical directions. As you can see, the results indicate a substantial contribution to the deformation of the vertical component in comparison to the horizontal. The maximum rate of displacement in diapirs approaches 8 mm per year. To investigate the vertical displacement rate, we extract 6 profiles crossing the salt structures. For instance, for E prime profile, the graph shows the displacement rates in the vertical direction versus topography along the profiles. For visualization purposes, we depict the diapir's boundaries with red color line on the optical image and red rectangular at the bottom of each graph. As you see, there is a meaningful correlation between displacement, actually uplift, and variation of topography. This correlation is related to the activation of D7 diapir, which moves up at a rate of 5 mm per year. Based on the remote sensing mapping of superficial geometry and their surrounding strata, we categorize the salt structures in the Kalut into 4 types. It consists of salt walls, salt massif, salt stocks, and salt wells. As for salt wells, this figure presents the location of 3 wells. We have correlated the maps of salt wells in this area with the InSAR results. None of the wells shows the considerable vertical or horizontal displacement. So this suggests that Kalut salt wells are not active. In conclusion, all salt structures are active in this area. Maximum rate of growth reach 8 and 2 mm in vertical and horizontal direction respectively. And the remote sensing mapping has been used to classify salt structures in the Kalut basin, which include 3 salt walls, 4 salt wells, 4 salt stocks, and 1 large salt massif. For more details, you can have a look to our paper. Thank you for listening.